So you have a couple different types of tiles. The first is this green rectangle. This algebra tile represents our variable. We're going to refer to it as x, but it can really represent any variable in an equation. We just most often see it as x. When you have a red rectangle, that is representing a negative variable, so we're going to refer to that as negative x. This yellow square represents a unit, or a positive 1, so I'll refer to those as units a lot of times. The red square is negative 1. Now that we've identified our algebra tiles, I want to talk about one more thing that's going to be really useful as we're solving our equations. So something that you're going to hear me refer to is a zero pair. Okay, so what this is, I'll use units for an example. So if I have a single unit, a positive unit, and a negative unit, if we add those together, combine them together, what would that make? Positive 1 plus negative 1. That's going to make 0. So we refer to a positive and a negative unit together as a zero pair. You can make zero pairs with variables as well, but for our example today, we're not going to have to worry about that. We're just going to use it for units. In this video, we're going to look at how to solve a one-step equation that involves a negative coefficient using algebra tiles. So our example is negative 3x equals 6. So let's go ahead and use our algebra tiles to represent that equation. On the left side, I have 3 negative variables, or negative 3x, and on the right side, we have positive 6. So we're going to use 6 yellow tiles. Okay. So we always keep in mind when we're solving equations that we want to end up with a positive variable x. Now, if we look at our equation, we don't have any positive variables. We only have negatives. So that's okay. We're going to address that, but let's first try to think about these variables in terms of just a single variable. So if we have 3 of them, we can split those into 3 equal groups, 1, 2, 3. Okay, they each have a single variable. Let's do the same thing with our units on the right side. Let's split those into 1, 2, 3, 1, 2, 3 equal groups. Okay. So we can see in our groups that a negative x is equal to positive 2. Okay. Now that's great, but we need to think about it in terms of positive x. So here is something you may or may not have seen before. If we want to take a negative algebra tile and make it positive, we can do that by flipping the tile. Okay, so this is what I mean. I can literally flip that and make it positive, but the only way I'm allowed to do that is if I flip every single tile on this mat, okay? So if I want to make that positive, I need to flip that, that, and every single one of these, okay? So if you want to flip a tile, you can do that, but you have to flip every single tile on the board. If you were solving this algebraically, flipping a tile like that is the same thing as dividing by a negative. So we'll see that later when you're solving algebraically without using tiles. So let's look at what we have now. We now have that a positive x is equal to negative 2. So our solution is positive x equals negative 2. If positive x is equal to negative 2, let's go ahead and reset our equation back to what it used to be. So we have negative 3x is equal to 6, right? And for every positive x, so I'm going to use this to represent, every positive x is the same as negative 2 units. So anytime you're checking an equation, we plug in our solution in for the variable. So what we're going to do is we're going to literally plug in units in for each of our variables. Now our equation had negative variables and we got a solution that was positive. So we need to think about, instead of positive x is negative 2, I don't have a positive x to plug anything into. So let's think about it this way. If positive x is the same as negative 2, then negative x would be the same as positive 2. So we applied that same principle. If I flip one of these tiles, I got to flip them all. So Again, if positive x is the same as negative 2, then negative x is the same as positive 2. So for every negative x, we can substitute negative x with positive 2. So I'm going to take these off the board, and we're going to substitute our solution. Instead of negative x, we're going to plug in positive 2. Negative x, plug in positive 2. Negative x, plug in positive 2. And the question is our equation balanced? Does the left side match the right side? Well, on the left side, I have 1, 2, 3, 4, 5, 6. On the right side, 1, 2, 3, 4, 5, 6. Left side is equal to right side. That's exactly what we should see for an equation, and that means that our solution is correct.